So welcome everyone. This is 11.3, finding complex solutions of quadratic equations. And in this lesson, we are going to use completing the square and quadratic formula as our two ways to solve quadratic equations. We learned those two methods in module 9, okay, 9.2 and 9.3. We're going to use those two tools to solve these guys. So first, a really quick review on completing the square and quadratic formula. Remember, completing the square, there are three rules to remember, okay? And it's all based on your A value. So the first rule is if your A value equals 1, then we are just going to complete the square, we're going to use the B, half B, square it. Okay, we're going to use that as our rule. The second rule is if A is a perfect square, right? If A is a perfect square, then we are going to use B squared over 4A to complete the square. Okay? And the third rule is if A is not a perfect square. Okay, and that includes 1, right? Then this one, we're gonna make my A value equal to 1 or a perfect square. And then we're gonna use one of those two rules, okay, depending on what you make it. So you're gonna divide it by that number or multiply it by some other number, right? Okay. And then with so that's with completing the square. With quadratic formula, all we have to remember about the quadratic formula is the quadratic formula itself. So remember the quadratic formula. First, you have to make sure that it's in this format, ax squared plus bx plus c equals 0. So you have to make one side equal to 0 first. And then remember it's x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay? So those are the ways that we're gonna show this. Okay? All right, so completing the square or quadratic formula. Or if it's nice and neat and already good, we're just gonna take the square root. Okay, so here is our first example. X plus 5 quantity squared equals negative 25, right? So our first step here is to take the square root. Once we take the square root, then it's x plus 5 equals square root of 25 is 5, and then since it's a negative, an I comes out. Okay? And whenever we take the square root, remember that we do need that plus and minus. Okay? It's always going to be plus or minus. Okay? Our next step then would be to subtract 5 on both sides. And your answer or your solution would be negative 5 plus or minus 5i. Please don't forget the format, okay, with the plus and minus in between. All right. So that's your solution there. Okay, any questions? Yeah. You can add and subtract real numbers with imaginary numbers to make it a complex number. But you cannot simplify from there. Okay, so notice that the real number is on its own and the imaginary number is on its own. And we're adding and subtracting it, but then we're not going to do anything else from there. Okay. All right, so what I want you guys to do is to try that one. All right. Take about a minute and try it, and we'll be back. Going over this really quick. We're going to square root both sides. And then my left-hand side is x plus 3 equals plus or minus, because I square rooted it, negative, so there's an I, square root of 16 is 4, right? And then I'm going to just subtract 3 on both sides. Okay, so your answer should be x equals negative 3 plus or minus 4i. Okay, yes. Because the 4 is an imaginary number because it's the I. So you never add or subtract a real number with the imaginary number. And we can't simplify it, I should say. Yeah, so just if you treat the I just like a variable, yeah, you wouldn't add 4x plus 3. Yeah, same idea here. Okay. All right, so if we get it down to this format by completing the square, we should be good, right? So if we have this as our next example, what are the roots of the equation x squared plus 4x plus 13 equals 0 in the complex root form? This is just asking us to solve it, right? And we can use either method. On your assessment, though, I am going to specify what tool to use to complete the square or to quadratic formula, and we can talk about more about that after our lesson. But in this case, I am gonna use quadratic formula. Okay, let's quadratic formula this. And remember the quadratic formula, right? Our first move is to make sure that our equation equals 0, which it does, right? It's already equal to 0 here. So from here, we can get our A value, which is 1, our B value, which is 4, and our C value, which is 13, right? So x equals negative B plus or minus, I'll just write it out actually. X equals negative B plus or minus square root B squared minus 4AC all over 2A. Okay. And my first move here, class, I know it's gonna seem very simple, which is the point. Okay. If you have a calculator right by your side, the math, the numbers shouldn't be a problem, right? You're just plugging it in to your calculator and getting the answer there. The only way you can mess this up is if you put in the incorrect numbers, if you simplify incorrectly, okay? All of those simple errors, right? So to avoid those simple errors, I just like to put blanks on all the A's, B's, and C's, right, of the formula. And then my next step would be to plug it in. Literally be a robot and just plug it in. Okay, don't try to simplify while plugging in, but just plug in the numbers, right? Literally be a robot and plug in the numbers, and then use your brain to simplify. X equals -4 plus or minus square root. 4 squared is 16 minus, oh, not minus. I wouldn't even put the minus in there. When we are simplifying this, right? This part there, -4 times 1 equals -4. -4 times 13 is 52, right? -52. So since your answer is -52, put that down, -52. Okay, if it's a negative, we're subtracting the numbers. If it's a positive, we're going to add the numbers. Okay, and then divide it by 2 times 1, which is 2. Right? And then so x equals -4 plus or minus square root. 16 minus 52, that is -36. Divided by 2. That will be -4 plus or minus. What is the square root of -36? 6i. Okay, because it's a negative. Square root of 36 is 6. Since it's a negative, there's an I in it. Divided by 2. And when we are simplifying -4 plus or minus 6i divided by 2, remember we have to look at this number, the -4, the 6, along with the 2. Okay, we're going to have to look at all three numbers and find the GCF, the greatest common factor, or a factor. Okay, if you can't find the greatest, then you can just do it multiple times. Between 4, 6, and 2, what's your GCF? 2, right? So if you divide everything by 2, this would be -2. The -4 would turn to -2. 6 divided by 2 is 3i. 2 divided by 2 is 1. So that would be your solution here. Okay, which x equals. Yeah. Cool. Okay, so that is the quadratic formula. And try and be as systematic as possible. Okay. So with this one here, what are the roots of the equation x squared plus 2x plus 50 equals 0 in simplest complex root form? Since I showed you one in quadratic formula, I'm going to show you this in completing the square. Okay. So my first move in completing the square is to subtract 50 from both sides because I want, or I need, my constant to be on one side by itself. Right? Okay. And then we are going to check this coefficient. Since that coefficient is 1, yeah, we're going to get b, which is 2, half it, and square it. Okay? So half it divided by 2 and square it. So 2 divided by 2 is 1. 1 squared is 1. And we're going to add that number here and here. Okay, so we're going to add this number here and here. Right? So I'm going to rewrite it just so that it looks nicer and we can kind of dive into what's going on here. And then this would be -49 if you simplify that. Now we're going to build the perfect square, right? Equals -49. When you build that perfect square, all we're going to do is take the square root of the first term. So what is the square root of x squared? What's the square root of x squared? X. What is the square root? And then we're going to square root the last term. What's the square root of 1? 1. And since this is a plus in between, this is also going to be a plus. Okay? So that's how you build it, and I'll rewrite it in one color. So again, we can work with it. Okay? And then here, we're just going to do the same steps as above, right? So take some time to solve this guy. And I already did the first step for you. Okay, we are gonna square root both sides. So square root both sides and go. So this is the work that you guys should have done. We square rooted it, right? And then we subtracted 1. Cool? Okay. So my next example, you guys are gonna do. Now with this one, I will give you guys both quadratic formula and completing the square works. Okay? For all of them, it works, right? But there is a more efficient way. So before I let you guys go off and do this, my C value here is really big. It's 196. Yeah? And if you plug it into the quadratic formula, where it's b squared minus 4ac, it's going to be a huge number, right? 4 times 196 times your a value, which is 1. Yeah, 4 times 196 is a huge number. Yeah, you're going to have a calculator there, right, on the assessment. But we are also going to have to simplify. Okay, so you're going to be like an accountant if you use the quadratic formula, meaning you're going to be doing a lot of calculator work, right? If you use the quadratic formula here. So the more efficient way would be to use completing the square. Okay, so try that out. You guys can use the quadratic formula, right? We're gonna subtract 196 from both sides. And then we're gonna have x squared minus 14x plus blank equals negative 196 plus blank, right? And so we're gonna get the negative 14, half it, and square it, right? Because my a value is 1. So when we half it, that's negative 7. When we square it, that is 49. So I'm going to add 49 here and here. So we're going to have x squared minus 14x plus 49 equals negative 147. Right? And when we build our perfect square, remember, square root of 49 is 7. Square root of x squared is x. Since this is a minus, this is also going to be a minus. Okay? So the next step then after this is to square root both sides. And then we have x plus 7 or x minus 7 equals the square root of negative 147, right? Okay? 147 is a weird number, right? It's an odd number. We don't really encounter 147 a lot in math when you're doing your problems. So I would think of an odd perfect square. 25, no. 49, yes, right? Divided by 49, that's 3. So 147 breaks out to be 49 times 3. So if it's 49 times 3 minus 7 equals square root of 49 is 7. It's a negative, so there's an I, square root of 3. Right? What did I forget? Plus or minus. Okay? And then I'm going to add 7 to both sides. And your solution would be x equals 7 plus or minus 7i square root of 3. Okay? All right? So those are the steps to this problem. Any questions? Again, you can use completing the or quadratic formula, right? But then you will be an accountant trying to figure out how to break down, I believe, 588. Yeah. Okay. So in this case here, our next example, 9x squared minus 12x plus 8 equals 0. I'm going to show you completing the square. Okay. So when we complete the square, I have to make sure that my constant is on one side. So I'm going to subtract 8. So 9x squared minus 12x plus blank equals negative 8 plus blank, right? Now, my coefficient is a perfect square. 9 is a perfect square. So I'm going to use b squared over 4a. So if I use that, my b is negative 12. So negative 12 squared over 4 times 9, which is 144 divided by 36, which equals 4. Okay? 144 divided by 36. Any questions on the steps here? I noticed that my a value is a perfect square, so I have to use b squared divided by 4a. Okay? Which I did, simplified it to 4. So I'm going to get that number and get this number 4 and add it here and here. Right? So remember how we complete the square. Yeah. All we're going to do is get the square root of this number, 9x squared. What's the square root of 9x squared? 3x. Yeah. What's the square root of 9? 3. What's the square root of x squared? X. Okay, and then square root 4, square root of 4 is 2. And since this is a minus, this is also going to be a minus. Okay, since that's a minus, this is also going to be a minus. Okay, equals negative 4. And then we can proceed by taking the square root. So 3x minus 2 equals 2i plus or minus 2i. Add 2 to both sides. So we have 3x equals 2 plus or minus 2i. And then just divide it by 3. Right? Taking the steps to solve for x. That is all we are doing here. Cool? Yeah? So in this case, if it's a perfect square, if your a value is a perfect square, please remember to use b squared over 4a instead of halving it and squaring it. Okay? All right. My last example for today is this. And for fun, I'm going to use quadratic formula. I don't know how fun it's going to be, but we'll see. Okay. But I do want to emphasize to be a robot when using the quadratic formula. Okay. So it's 4x squared minus 20x plus 29 equals 0. So since it equals 0, my first step is already done for me. So my A value is 4. My B value is negative 20. And my C value equals 29, right? So x equals negative b plus or minus square root b squared minus 4ac. Notice that I'm just putting in parentheses, right? Of the letters all over 2a. Okay. Now b is negative 20, so x equals negative b. So this is b. So that's negative 20 plus or minus square root b squared. So that's negative 20 squared minus 4a, which is 4, c, which is 29, o all over 2a, which is 4. Yeah, literally just plugging in the numbers, not even simplifying them, right? Just making sure that I'm plugging in the correct number. Okay. So if I simplify, x equals negative times a negative is a positive. So positive 20 plus or minus square root. Negative 20 squared is 400. Negative 4 times 4, that's negative 16. So negative 16 times 29, that's negative 464 all over 8. 2 times 4 is 8, right? So this would be x equals 20 plus or minus square root of 400 minus 464 is negative 64 divided by 8, which you would get 20 plus or minus 8i all over 8. And then we're going to look at this number, and this number to figure out how to simplify this. 20, 8, and 8. What is your GCF? 4, right? All goes into 4. So if I go 20 divided by 4 is 5 plus or minus 8 divided by 4 is 2i over 8 divided by 4 is 2. So that is my answer. Cool? Yeah? What I did not go over, and sometimes you might see, is the negative 64, right? Might be a negative 128, or it might be not a perfect square, right? A negative version of a perfect square. It might be a number where you would just have to simplify it, right? And there's still a number in the square root. Okay? Other than that, the steps are all the same. Cool? All right. Thank you very much. And